In this video, you'll learn the basics of working with PDB files in PyMOL. We'll start with simple exploration and built-in presentations, then move on to creating publication-quality images and even simple movie clips.
Dr. Chem Informatics.
First, we download the PDB file by using the PDB ID. So I added the PDB ID here, and simply I can choose the chain that is going to be downloaded. But if you want both chains, you can simply click on download. Then the whole PDB file and PDB data will be downloaded. So you can see the receptor, which is a kinase, and the inhibitor inside the binding packet. Then, for example, we can change the color by using the right panel, and simply by clicking on the C, letter C here, you can change the color of the whole object, after all of objects in the environment, or just the one that we have here as 7SJ3. Also display the sequence by using the display menu tab there, and you can see the water molecules and the ligand, which are both of them are included in the sequence. So they are basically the water molecules. If you want to make any selection, you have multiple options. But before that, if you want to clean the structure, we usually need to remove or hide the water molecules, which I just did. So I removed the water molecules, but you can also hide them instead of removing them by using the hide menu, which is shown by letter H at the top right corner. If you want to select a residue, which you can either use the sequence viewer up there, and using the shift button you can select multiple residues, and again you can do, for example, you can remove them, or you can change the color of the selection, or whatever you want. Or the other way is to clicking, or you can use the command line of the Python, which is more sophisticated. So if you want to rename your object, so I just copied chain B to another object, and now we can rename the object to chain B. So now we can select which object we want to be visible in the environment of PyMOL. So now we have only chain A visible, and also the co-crystallized ligand. As I said, you can either hide the objects by using the, or part of the objects by using the H menu, or you can show anything you want by using the S menu here. And I just select the ligand, and I'm going to extract this as a new object, and again I rename it to ligand, and it will match. It's very easier to work with this complex. And now I can change the, I'm going to show you that various coloring that we can have. This one is useful when you want to, for example, working with the GPCR receptor or other receptors that the N-terminal and C-terminal position is very important to you, and you want to be which, for example, you want to identify the number of the helices and identify a specific helices. But usually you want to color the receptor like this with one color. So here I choose the gray one. But if you want to have the atoms colored by their type, for example, the oxygen red, nitrogen blue, you have to color by element, which I selected here. Otherwise, all the atom types can be colored by the same color, which is not ideal. By default, usually the PDB files does not have hydrogens, and you can add the hydrogens automatically using this feature in PyMOL by using the A menu and add the hydrogens. And so yeah, this is really important when you want to show the interaction of the ligand with the receptors, which you need to have at least show the polar hydrogens. But here, as it is expected, the PyMOL is not a specific tool to identify the best protonation state or the real protonation state of the ligands, at least. And here you can you can use other tools and know that this nitrogen here should be protonated at pH 7. So I'm going to add the hydrogen manually to this atom, and you can see that it has been added. And if you want to get rid of this +1 label, we can remove the label by using the H menu and hiding the label. Now we have the correct protonation state of the ligand, and the other thing is that the behavior of the left button of the mouse is defined by the right bottom panel here. So you can change the type of the selection that it will be able to do. For example, so by default it is residues, but you can change it to atom, molecule, or object, and it will define the behavior of the left click. By the middle click, you can translate the object or view to be exact, and by left click you can rotate the object, and the last thing is that by right click you can zoom in and zoom out. The other thing is that here from the A menu we can select center, orient, or zoom, and it will be focused, the view will be focused on the object that you used for the orienting or zooming the view. And when you want to define the binding packet, the best way is to first select the ligand and then go to A menu, modify, around, and select the residues within a particular distances from the ligand atoms, which is here I selected 6 angstrom, and as you can see it will select the nearby atoms of the nearby, so the atoms of the nearby residues. And again, for the convenience, it's better to rename the selection. I will change the name of the selection to BP, which is binding packet, and then when you want to change the representation of the type of the binding packet residues, we can easily do it by editing this selection, which is called PP. With over here, I assigned them to be shown as lines. Anyway, if we want to fine-tune the representation style, we can use the setting menu, and here, for example, we can change the width of the line representation. So I increase the thickness of the line. And another important is that if you go to the A menu for the ligand objects, we can find the polar contacts here, and if we click on the polar contacts and we specify the type of the polar contacts that we want to see, you can actually see the hydrogen bonds, which are usually important if you want to explore the interaction between the ligand and receptor. The other things that might be interesting to you is to change actually highlight specific residues within the binding packet. You can do it, for example, by changing the representation or color. So I just click on the two residues and change the representation to a stitch, and also I can change the color of them, and I created the new object from them to make working with them easier. So now I am going to change the color of the new selection, which is called residues under line 1 to pink, and so now you can see that they are kind of highlighted. And you can also have a surface representation. One of them is mesh, so you can see the surface in mesh, and you can use the middle wheel of the mouse to select how deep you want to see the binding packet. You can use the middle button to fine-tune the representation and make it more clear. Also, you can see the surface in solid mode, which is shown here. And another option that you can use is the transparency. So I use transparency to make the view more clear, especially if you want to publish an image for your project. And I set it to 60 or 40 usually. And also you need to make the background white, because it is much nicer for a publication quality image. So here we can do some more editing to make it more appealing for as a publication quality image. For example, we can add labels. I just add them for the residues. You can increase the size, and also you can see that the position is not very actually optimal. If you want to change the position of the labels, we have to change the viewing mode to editing mode, as I just did by clicking on the box bottom right, and then by using Control and left mouse button, we can drag the label. And if you accidentally drag an atom, you can use Control Z to revert to undo the dragging, the last dragging. So here you can see that by rotating the molecule and repeatedly editing the position of the label, we can adjust it. Of course, you can also remove the labels and add the labels by other softwares later. Here are the options that you can choose, that you can change if you want to save a rendered if you want to save a rendered image, you can have the background, or you can choose to have a transparent background, and you have to be sure that you selected the ray option, because then it will add all the shadowing and other beautiful stuff, as you can see here. So this is the saved image. If you select the render option, you can see the shadowings and other rendering. You can also do some fine editing. For example, here we have some residues that are not necessary if you want to show the bond interaction of the ligand with the receptor, and they kind of block the view, so we can hide them. So I'm going to select those residues and hide them using H menu. And also here we have a lysine that should be hidden. Now we have a much more clear view of the ligand interaction with the receptor. And also we can again adjust the position of the labels. And it is a matter of taste. For example, if you want to also, or if there is a specific reason that you want to also show the cartoon, you can change the representation to cartoon as well, but usually it is better to make it a bit more a bit transparent. So just like what we did for surface, we can also make the cartoon representation transparent, which makes the view more clear. Now everything is fine, and we can save the image using the ray option as I said before. Depends on your system, it takes a few seconds, 2 minutes to produce the ray rendered image. And if you want, you can also create a short video clip, so it's very nice for your presentation. For example, here you can use so it is the simplest video that you can create by using the rack option that I just showed you, and then by clicking on the bottom right play button, you can play the clip. And if you want to save a video clip in proper format, again you have two options, one to use the render and another one to actually save it in correct shape. But be aware that this time selecting the render will take half an hour. Thank you for watching this tutorial.
Support us by liking and subscribing to our channel.